Okay, yeah. Hello everyone. My name is Ronny Dörbeck from the company ese-robotics here in Jena. What's with the keys? Yeah, we are a medium-sized company with 15 employees, and we not working like the most here on a scientific way or in a construction way. We only offer normally service from robot programming. In this way, offline programming, online, and developing of standard functions you need in your code. So maybe most people don't know what means offline, online. So offline means the complete work before. You make a virtual first commissioning of any station with a robot. You get a full CAD with all mechanics inside, and then you are able to test every process you want to do in this station before you start with the layout in the construction. And in this case, you also see if you get any problems about collisions or cycle time, whatever, you can prevent it before you start to set up the station. And we also use it, for example, before this will done also for reachability test. Is the robot able to do the job what he should do or not in general? So if this is done, then you normally go to the online programming. This means two ways. The classic way is you go on construction site and just start, and you need a long time, because if you get any problem because something is in the way, you have to find a way. So the new way is to say we make before these offline programming, and then we have every problem solved, and we just have to run the finished programs and see that it works. I have here also, I'm not sure, hopefully it works. This is just a small video to show how it then looks in the end, and if you have to program these I think 8 robots by hand, you will first take a long time, and the biggest problem is the collision sounds, because you see the robots are working on the same places, and they normally don't know that the other robot will also works there, only if you tell it them. So if you don't want to increase the costs of your customer, you should make before offline simulation and test these all. Otherwise, everybody will talk about you, but not good. So, yeah. And what we also do online, this I forget to write down, sorry, is we also work a lot on optical measurement systems. For example, company size with inline measurement. That means you have a robot station with 3D camera sensor, and you measure the dimension of the car. Its accuracy or not. It's just a quality tool this way. And so we get a lot of experience about optics, or the usage of the optics, we call it like this. And that is the reason that we also start to make more development. But before the last point, this is fast, no? Yeah. I also write down development of standard functions. This means just coding. The programming language of a robot is a simple language, like the most programming language. If you have any special application, for example, here this is just for controlling a gripper, you have to define by yourself. Or you make it on basics, but this is not useful. So this we also do if a company don't have robots, means they don't have a robot standard, and they need some protocols for communication, PLC, components, whatever, and this we also do in the robot language. So, and then what I tell you, before we start to do own development, we looking for a new orientation, because we have a lot of experience and we know what works really good on the real side and what not, because many companies offer things. But in the laboratory maybe it works, but in real you get problems. I think many people you also know. And so we think about to take some things we know is not really good and find a better way. But this means not that we invent something really new, because like we hear before, many things will be developed years before, but mostly not used. And so we think also just say, okay, we take all is there. Our target is to say, we take our experience about optical measurement and image processing and put it in new solutions for, would better work for us. And we have also the point that we say our solutions should be small and not influence the working process, because many components just too big, even today, could be smaller but will be not, because of the price maybe. And mostly of the components also overloaded the features, but you will be only do one thing. So we think about to make simple solutions, and then of course can get on a low level price what will be for smaller companies more interesting than a system for 10,000, 20,000 euro just to measure a hole. This is not really useful. So our idea we called PinCam. Here I show, where is it? Some pictures. You see, this is normally the robot gripper, and he has some reference pins to grip the parts about the correct positioning. And the problem is mostly the parts will be moved so much that the robot will be not get in the hole. So you need a camera to make like a exact accuracy positioning, and these are solutions you normally find on the market. So you see here's the gripper, camera is there. This one is really funny, the camera is 90 degrees turned. That means at this you see about the size is not really small, and when I have solutions like this, means I need a lot of space and time to first measure the part and then to grip it. And we think about do it in one style, and that is the PinCam. Means we looking for a good camera and found here in Jena. Is small and still full HD. This is for our usage enough. We need an accuracy about 0.1 millimeter, because the robot is not exactor, so we don't need more. And we find a small camera, and our idea is we put this small camera in a pin, in this reference pin, so that if the robot goes to the position, he look exactly in the hole he want to drive. And so we save a lot of space, and also about movements, because we are on the way directly. So this should be looked then like this. Here we have this camera. This is from the company Opticron. We must make a little bit commercial also for them. Have also one here, just to maybe imagine about the size. Yeah, this is the size. Maybe, I'm not sure everybody can see. So, but it's just a simple camera, but can full HD, and our idea is, when you see here on this picture, these are the gripper from the robot, and here these orange ones, these are the reference pins to take the part. And we can put one camera in the first pin to get the position. This is the TCP camera. TCP tool center point is the reference point of the robot where he makes his movements. And the second camera additional can use to make the orientation so that he get the part perfectly. And so we can reduce the case of crashes, also the damage of parts, because mostly we have only thin metal sheets, and the robot has something about 200, 300 kilogram. He not care about a 1 millimeter metal sheet. So you damage the parts, and when you then produce cars, for example, like this, you get an error inside, and you put this error from part to part to part. So it's not really useful, and we think our idea is good. We are just in the developing it. It should be hopefully finished end of this year. And we already know about some customers who are really interested in this idea. So let's see what it was. And here, just this is a picture of this camera. And you see the resolution is good enough to make a simple measurement from a hole. So just some ideas more. We also think about to put these cameras maybe in a gripper directly, that we also, when we have to pick a part, just search it and then pick it directly. So this is the next step. So that's all. Thank you very much.